Hello, my dear student. Today we shall discuss our next topic, that is laws of refraction of light. Okay, laws of refraction of light. So, first law is given here. Whenever light goes from one medium to another, the frequency of light do not change. Only wavelength and velocity of light changes. We have shown a figure earlier that this is the glass medium, and let an incident ray of light is falling obliquely. Here is the incident point. When we are drawing a normal here, in that case this will be the angle of incidence. Is it visible to you? Okay, yes. Then if it is the rarer medium, the first medium is the rarer medium and second medium is the denser medium. So where should that incident ray go after refraction? It will bend towards normal. Okay. Another point, if we are going to draw another normal here at that point, then this ray has to move again from denser to rare. It will bend away from normal. That we have learnt in our earlier discussion. So why it was happening? It was happening just because of that. Because whenever ray of light passes through different mediums or different materials, its velocity changes. What is the reason? Why change in path of light is taking place? So answer is because of changing its speed. Because of changing its speed, as soon as it passes through different mediums or different materials. Okay, that was the reason that we have learnt about here. But is there any more characteristics that may change? Yes, of course there are. What may be the different things that may change or may not change? So different characteristics are related with a ray of light. First one is its frequency, next its wavelength, then its speed, and one more thing, phase of the light ray is also there. But here in our 10th class discussion, we have to concentrate ourselves on the term frequency, wavelength and velocity. Because already in 9th class we have discussed in the chapter of sound something regarding frequency and that velocity and wavelengths. So you can easily understand. That's why I have taken only frequency. So frequency is something which determines the properties of some material. Okay. So in 9th class we have learned that energy depends upon that frequency. We have also learned that frequency means how much time a thing is taking to change itself, or how many time an oscillation was taking place. Okay, that was the frequency. Means it is the specific characteristics of something with which we can say that how much energy is related. So my dear student, here in case of refraction of light, when we are talking about frequency, so frequency of light does not change. So it is the permanent characteristics of light while passing through different mediums. So what may change? Speed may change, and that change in the speed causes bending in the path of light, and another wavelength of light may change. I hope you are well familiar with that relation. That is, speed is given as equal to frequency into wavelength. Is it visible? A little smaller size is there. I will try to increase the font size, but I hope you are listening me carefully. So speed can be given as the relation of frequency and wavelength. If we denote speed with v, frequency with f, and wavelength with lambda, then we may have that relation. Frequency may be written as V upon lambda. So frequency of the light does not changes as it passes from one medium to another medium, but its velocity change may take place, its wavelength change may take place, and these changes will take place such that that frequency remains constant, and ratio of two quantity maybe remain constant only, if one quantity is decreasing, another quantity will increase. Okay, that was the about frequency. And first law of refraction of light, that the ray which is passing through one medium to another medium, its frequency doesn't change, but its wavelength and speed changes. What was the another rule or another law of refraction? It was simply that incident ray, this one, this normal, and that refracted ray all lies in the same plane. This was the point 2. Incident ray, this one, that incident point, normal on that point, and that refracted ray all lies in the same plane. What was another important? Okay, dear student, let's discuss rule 3rd of laws of reflection, okay, in detail. So it is mentioned here, the product of refractive index and sine of angle of incidence or refraction at a point in a medium is constant. Listen, at a point, it may be here or it may be here. We are considering some point, okay, such that if this angle was R, it may be also considered as R, as alternate angle, and we have earlier discussed about that this angle should be equal to this, because emergent ray and the incident ray in case of a glass slab are having same angle, okay, that we have learnt of from our discussion. So now according to this third law, we can write that mu, which is known as the refractive index of the medium, into sine of angle of incidence. That angle of incidence is here I. According to third rule or third law of refraction, it should be equal to constant. When something is written like that, it is equal to constant, it may be expanded as mu1 sine I1 is equal to mu2 sine I2. Further, it can be written as, rearranging this one, it may be written as mu2 by mu1 is equal to sine I1 divided by sine I2. Here sine I1 is equal to this incidence angle, that is sine I, and I2 is equal to this angle of refraction which we have denoted by R, as it will be equal to sine R. So mu2 by mu1 may be written as equal to sine I upon sine R, that is sine of incidence is equal to sine of R, okay. And this ratio of refractive index, mu2 is the refractive index of this medium, mu1 is the refractive index of first medium. So refractive index of second medium with respect to first medium may be also calculated in terms of sine of angle and sine of angle of refraction. Okay, dear student, this ratio can be written as mu2 that is refractive index of second medium with respect to first medium, that we have learned earlier. So we can calculate means how to find out refractive index of medium. If a refractive index of first medium is given, second was not given, so by using this rule we can find out the refractive index of second medium. Okay, dear student, although a table of different medium is given to you having different refractive indices, but let you are not given the refractive index of second medium, so you can find out its refractive index while considering first medium as air or vacuum, and measuring this angle of incidence and angle of refraction. So this is how we can calculate the refractive index of some medium. This rule is known as Snell's law. This rule is known as Snell's rule or Snell's law. So simply you can say that in case of refraction, the rays of light are going to obey Snell's law. If someone asks you what do you mean by Snell's law, Snell's law means you can write down mu1 into sine I is equal to mu2 into sine r. This is known as the Snell's law. Either write in this form or either write in this form. Okay, dear student. Now let's once again try to learn how to apply Snell's law, because Snell's law will help us to calculate the refractive index of a medium. If refractive index of a medium is calculated, then that can help us to find out the velocity of light in that medium. How it can help us? Because we have already discussed about refractive index. We have already done about refractive index, that it is given as velocity of light in the vacuum to the velocity of light in the medium. Velocity of light in the vacuum to the velocity of light in the medium. So for diamond, if we talk about diamond, the refractive index is 2.42, and in vacuum we are confirm about the velocity of light. It is 30 into 10 raised to power 8 meter per second. And if we need to calculate that velocity of light through that diamond, it can be calculated. V is equal to 30 into 10 raised to power 8 divided by 2.42. Means it will become 1 by 2.4 times the velocity of light in vacuum. So let's try to recapitulate what we are trying to say. क्या कहना चाह रहे हैं हम लोग कि let this was the ray diagram. Okay, then this ray diagram will obey Snell's law, which is one of the very important law of refraction. How? What is the statement of this law? Statement of this law is like that: refractive index, that is product of refractive index and sine of angle or sine of refraction, is always equal to constant. Okay, if something is written like that, it may be explored in that terms: mu1 into sine I1 or mu2 into sine I2. Okay, further, this sine I1 is equal to I, that is angle of incidence. What will be sine I2? I2 means angle of refraction. R is here. So dear student, we have calculated refractive index of second medium with respect to 1, and when we have calculated refractive index of second medium, we can calculate the speed of light in that medium while using this formula. One example we have given to you. So this is the importance of Snell's law, or you can say even it is a further importance of refractive index. That what we can conclude, if refractive index is there, we can compare refractive index of two media. The medium with more refractive index will be more denser, and another one we can calculate the speed of light easily in that medium. Let's try to learn how to apply this Snell's law for better understanding. Try to apply Snell's law. So simplest way, we are going to tell you that it was point A and it was point B. So my dear student, if we are applying Snell's law at this point, what to do? Write down the, first of all, write down the refractive index. Write down the refractive index of the first medium, that is mu1. Then sine of angle. What angle? This angle from where it is entering. Then put a mark of equal to. Then in which medium it is entering? Second medium, which is having refractive index mu2. Then sine of next angle, that is angle of refraction. So this is how easily we can apply that Snell's law using this formula. Let's try to apply at point B. At point B, if we want to apply Snell's law at point B, how it is going to take place? We have to start from this medium, and for that mu2 is the refractive index, and instead of sine I, sine of r is there. Okay, further we are going to the next medium where refractive index is mu1 again. So mu1 into sine of that angle we have considered, we have taken this angle I. Hence once again it can be written as mu2 by mu1 sine I upon sine r. In both the cases we have reached on the same result. In both the cases we have reached on the same result. Okay dear student, this is how we can apply Snell's law to calculate the refractive index of the medium. Then as soon as refractive index of medium is calculated, it can be used to calculate the speed of light in that medium. So these were a few laws of refraction. Next we shall discuss about refraction by spherical lenses. Okay, so wait for next topic.